Hello, my name's Tim Butler. I'm a commissioning agent and the owner's rep for this energy innovation project for Pittsburgh Gateways. And we're going to go walk through and look at some of the technologies that we're utilizing in this project. It's a LEED Platinum project, and so we have some advanced metering and measuring and going on in different types of system scenarios. This first scenario on the wall would be a local fan coil unit, and we're actually measuring the flows of the chill water and hot water, and the devices are on here and the control valves, temperatures. So we're able to calculate the load of each individual space and each individual tenant as we go through the building in order to maintain our LEED Platinum certification. Within this facility, we're using some innovative technologies. And during the design process, you'll see that we've color-coded all the infrastructure in the building for the learning purpose. We have on this side, we have blue and orange conduits would represent, the blue would be data, the orange would be fiber optics. We have a total fiber optic infrastructure within the building. We also have yellow conduits, which are power conduits. Red would be life safety, and any black would be building automation system conduits. On the ductwork, we have the brown, which would be our exhaust. The blue would be our supply air, and this is a non-conventional building, non-conventional system. We're using dedicated outside air systems, which we'll see later, brings in 100% outside air, exhausts 100% of the air that it brings in, and exchanges the BTUs through some enthalpy and heat recovery methods, and we'll cover that later on. You'll notice that the piping, which is directly behind me, we have a yellow hue piping, which is the hot water supply for heating, and we also have the blue colored, which is the chilled water supply and return. We also have color for domestic water, domestic return, and domestic hot water. We'll see more of this as we proceed through the building. You'll see LED lighting as we proceed through the building. We're using a state-of-the-art lighting control. As we go through the facility, you'll see that we have a lot of daylighting going on and daylight monitoring so that we can cut back on the light levels needed. We anticipate in the tenant spaces in the Sawtooth that during normal daylight hours that there will be no lighting requirements at all. We'll have, and we'll trim that lighting requirement off with task lighting. So basically, during a normal day operation in the office, no lights will be on. Part of our technology infrastructure are our local power and data drops, so that if we have work groups or tenants wanting to meet in the common areas, they'll be able to pull the data right from the ceiling and their power and utilize it on their workstations or any type of mobile units they can bring out here. It's also good for if we utilize the building for a convention of some sort, we can set up kiosks so that the vendors could have their own power and their own point of sale data drops if they wanted to utilize those. As you have seen, we've had multiple different configurations of technology here. These are horizontal fan coil units that we have in the corridor space. The blue duct coming out is our fresh air from outside. We mentioned before about the dedicated outside air systems. It comes into the building. The fan coil units actually trims and heats and cools that air. The air that's coming in is pre-treated so that it's either the humidity is at a stable pace and the air coming in is at a stable temperature. The fan coil units will do very little work in order to maintain that. We also can see the configuration of the piping, the chill water, hot water piping in each one of these units. And also the blue line, which is the color dew point, that takes any condensate that could be generated back to the central plant, and we'll use that water over again in our cooling tower system. We are currently in the new edition of the Energy Innovation Center, and you'll see how complicated of a building this is. This gives you a good perspective. The upper side of the floor that we're looking at above us would be level number 1. This would be level A and level B, and we have a total of, goes all the way to F level. So there's multiple mezzanines and multiple levels on this floor, which makes infrastructure difficult, operation, people flow, and we're working and trying to keep the temperatures and environment on a common, steady level for the occupants when they come into the building, which makes it more difficult at this level. As you will see out in the distance, we're facing north out of the new addition. We have Duquesne Lights transformers which feed power into the building. We also have the bigger green box out there is our emergency generator. We're in the main power distribution room, In this room, this is where all the power comes in from the public utility, Duquesne Light. We also have our generator feed here. This building has a redundant backup system for life safety. All our building automation systems are actually on the backup generator along with the elevators for egress. And our server room is on generator also. The one thing that makes this building different than every other building that we encounter is when you lose the power into the building automation system manages everything. What we have done here is we're able to manage the shutdown of equipment and the restart of equipment based on power outages, and that saves the life. It minimizes, for example, from electrical term, if we lose one leg, the building automation system can manage that. Typically, the whole building will shut down. We'll be able to shut that equipment and isolate it. We're also going to utilize these generators on demand response issues. So if we're in the heat of the summer, we're melting ice, we need to trim a little bit more electricity, we can start our generator and run the generator on all these systems and trim that power a little bit more so that we can reduce our capacity. This is the home of the dedicated outside air systems I've been talking about all the way through the building. These systems, the two gray boxes, actually bring air in from the outside, 100% outside air, whether the humidity is 90% or 40%. It brings it through the systems. We have high efficiency enthalpy wheel and heat recovery wheels. It brings the air in, sends it to the building through the blue ducts. All the brown ducting is exhaust air, so all the exhaust air we bring back through the building goes through that. We exchange BTU so we don't lose anything. And we actually pre-cool or pre-warm, preheat the outside air, and then we reduce the humidity if required, and then it puts the air right back into the building again. There's no mixture of air streams. It's just that it's all fresh air coming in and all the exhaust air going out. These 11 tanks is part of our innovative ice storage system. And what we will do at night is generate ice. We'll make ice into these containers. When the electrical rates are high during the day, instead of running the large chillers, we'll just melt ice and able to maintain the cooling in the building efficiently. In this area, we're going to have a large monitor, probably a 50-inch monitor hanging for the students. Students will gather in this area and we'll see the actual physical dynamic operation of these units on the graphic, and we'll be able to control them and show them the thermodynamics involved in the operation of each one of these pieces of equipment. We're here in what we're calling the observation deck. And the purpose of this room is to bring our students into this space and be able to look at the existing physical plan of the entire building. We have all the central systems below. We have chillers and heat exchangers and all the technology that we would use in the building. In this room also we would have a monitor on the wall, and it would be remotely controlled via an iPad or a tablet. And what we'll be able to do is shut the lights off and just focus on systems and show the students how the systems operate through the pumps and the pumping system and the heat exchangers and the chillers. And in this space would be the key for the students. It would be like a real dynamic learning classroom in this little space. Then once the students get experience enough, then they can go down into the area where the actual physical equipment is and see all the components and the field devices that are mounted on each one of those systems. We're currently in the main mechanical room for the facility. Within the mechanical room, we have our chillers, we have our motor control center. This is our motor control center. It controls all our pumping and chillers and all the other devices within the space. And you can see we have some in-depth metering going on here. We're able to measure exactly what kilowatt consumption that we are at any point of the day. Every device in here, whether it's going to be a temperature sensor or a kilowatt meter or whatever, we're taking a sample of that reading every 2 minutes so that we can do an in-depth profile on this LEED Platinum building. These are our glycol pumps. So these pumps strictly pump between these chillers and our ice storage tanks in the other room. And as we're pumping through here, during normal operation, this chiller is operating at a 41-degree operation. That's when we're bypassing, we're not making ice. But in the evening, when the electrical rates are lower, we're lowering the temperature of our chill water in our glycol down to 26 degrees. We send it to our ice farm, and we make ice all night long. This is the train control panel for just the ice making system. This facility has 7 different building automation systems in it, and we integrated them all into one front end. So the 7 building integration systems that we have, the dedicated outside air system has one, the boiler system has a second, the chiller has one, and we have other multiple building automation systems in the building. We've taken all that data via BACnet communications, and we're feeding it all into the Siemens base building automation system. So it's a true integration of multiple systems that a lot of buildings are not actually doing. This building is actually utilizing all of this data to come back into one front end. Most buildings, if they have more than one automation system, they have a front end for each system. We integrated that data here, and we're able to view it all off of one system, which makes it a bonus for the operators and the owners. Part of the base building automation system is a Siemens system. They're still working on this, adding all the points to it. At the end of the day, the building automation system will have over 5,000 points that we'll be monitoring throughout the building. It's probably 3 times what the normal building will have. As I mentioned before, we have 7 systems integrated into one. We've had a lot of interest from Siemens and Eaton and Trane to bring in their service techs to see exactly how they integrate systems and how we've done it on this project. Our building integration system is running on its own fiber VLAN, which makes no other building traffic from the data end, which would cause a slowdown of the transmission of the values. So we've designed in a VLAN just for data, and we're moving at such a fast pace. Every 2 minutes, there's a lot of data that we're collecting. We're going to have a true virtual automation system of the operating building. They can change values, they can mix values up and see what the response is. And the way we do that is as they change a value, we go back in historical data and see exactly what values were at that time, and we populate the graphic with that accordingly. These are our 2 boilers that will be handling the entire heat loss of the building, to replace the heat loss. So as you're operating the building, your heating demand is based on the amount of heat loss that you have in the building. And being that this is a LEED Platinum building, we have very little heat loss. In this entire boiler room, during the Conley Votech school days, this whole boiler room was just boilers, 3 giant fire tube boilers in this room. We went from those giant fire tube boilers down to these 2 small high efficiency condensing boilers, and these will serve the entire load of the building during normal operations. As I mentioned before, in the other areas we have a wide open space, and we have large walkways because we're expecting large tours of students to come through. And so if we have a group of students, they'll be able to mingle around the equipment and see exactly how that equipment operates, how it's installed, what the reasons each device is in their place. One of the items we've specified is significant amount of metering so that we can do our load calculations. The feature of calculations and loads are calculated based off BTUs. So if we can take our flow and our temperature differential, we can automatically calculate what our load is. And these load calculations are being fed back to our building automation system. Here we're going to the edge. We're using every capable operation of these systems we have in the building.